measures of location and spread, the standard deviation for ungrouped data. Example 5. So we have a group of boys. The mean height of these boys is 165 centimeters, standard deviation 4.3 centimeters, and there are 20 boys in that group. And we have a group of girls. Their mean height is 161 centimeters, standard deviation 5.1 centimeters, and there are 30 girls in this group. What we want to do is combine both groups together and work out the standard deviation and the mean for both combined. So we need an n value, so this value plus this one for the combined group. We need to work out a sigma x value from the mean for the boys. We need to work out a sigma x value from the mean of the girls, and then we add this value and this value together to get this one for the combined group. We use the standard deviation for the boys to work out the sigma x squared value here. We use the standard deviation for the girls to work out the sigma x squared value here for the girls, and then again we add this value to this one to get the combined sigma x squared value, and then we can work out the mean using these two for the combined group, and we can work out the standard deviation using the sigma x squared value, the mean, and n in here for the combined group. So calculations for the boys on this side in blue, calculations for the girls on this side in red, and in black in the center are the combined calculations for both groups. So n was 50, the sigma x values, again adding them together to get this one, and then using the formula for the standard deviation, rearrange to work out what sigma x squared is equal to. So we've got the sigma x squared value individually there and there for the boys and girls. Then add these two together to get the combined value, and then we can work out the mean and standard deviation for the combined group using only the values down the center here. What you can't do is just add that mean to that one and then divide by 2, or add this standard deviation to this one and then divide by 2. In part B, one more student with a height of 183 centimeters joins the combined group. So now we have 51 students. The sum of all the heights of the students, that's what we had before, plus this new one. And then the sum of the heights squared, we had that value from before. If we take this value now, square it, and then we add them together, and then we put everything into our formulae for the mean and the standard deviation. And the units for the mean and standard deviation are the same as the original units, centimeters. If we were to square the standard deviation, we get something called the variance, and it has squared units compared to the original units. When comparing data, we use the standard deviation and not the variance. The variance does have a use when we look at normally distributed variables. Example 6. So this is similar to example 5. We have two groups. Individually we have the means and standard deviations and n values for each group. We want to combine both groups, so all 50 student heights together, to work out the mean of the 50 students' heights and the standard deviation for all 50 students. So here are the calculations. I'm not going to go through these individually. So in blue, everything to do with the mean. In red here, everything to do with the standard deviation. And then finally in black, the combined group calculations. So the combined group had a mean of 167 centimeters with a standard deviation of 5.69 centimeters. For practice, try these questions.